Alright, we're going to start chapter P, section 3 on polynomials. Alright, we're going to start with discussing what a polynomial is. Now, a polynomial is a sum of terms in the form of k times x to the power of n. K can be any number and n has to be a positive integer. Right? So if that exponent over that variable is not a positive integer, then it is not a polynomial. For example, something like 3x to the power of 4 minus 5x to the power of 2 plus 7 is a polynomial, right? All of these have positive whole number exponents. Even something like 7 that doesn't have a variable, just the number by itself does count as a term in our polynomial. Now, in this example, 3x to the 4th minus 5x squared and 7 are terms. So terms are just anything that are separated by a plus and a minus. The numbers 3 and 5, or this should say negative 5, are coefficients. So coefficients are coefficients are just any number in front of a variable. All right, in this example, the number 7 is a constant. A constant is a number without a variable. All right, and the number 4 is the degree of a polynomial. The degree, we call that the highest exponent. All right, more words regarding polynomials. A monomial, that prefix mono just means one, is a polynomial with one term. So example, negative 5x squared is a monomial. A polynomial with two terms, right, that prefix bi means two. So a polynomial with two terms is a binomial, right? So something like 3x to the 4th plus 7 has two terms. And 3 terms is a trinomial. That prefix tri means 3, right? So 1, 2, 3 terms. And we call a polynomial in standard form if it's in decreasing exponent order, right? So if all the exponents are in decreasing order, then we say that that polynomial is in standard form, right? So something like this, 5x to the 4th minus 7x to the 3rd plus 2x squared minus 8x plus 13, right? All of these exponents we see are in decreasing order, 4, 3, 2, 1. If you don't see an exponent as 1. And then this has a degree of 0, right? This constant. Any constant is going to have a degree of 0, right? Because think of it like it did have an x, but it had an x to the power of 0, right? So all of these exponents are going down in order. The one without the variable is always last, right? Think of it like a degree of 0. All right, so these are some examples and non-examples. So something like 3x squared plus 12xy is an example of a polynomial, right? Because the x squared, that 2 in the exponent, is a positive integer, all right? And then x and y, both of these have positive whole number exponents of 1. So we say that this is a polynomial even if it's 2 variables, right? So something like the next one as well. The fraction might distract some people, right? You can have a fraction as a coefficient but not as an exponent. Same thing with the decimal, right? We can have a decimal as a coefficient but not an exponent. Same thing here, 4 and pi, right? Pi, we know, is a number. It's not a variable. It's a number. It's that 3.14 number, right? But our variables have whole number exponents, so 5 and then, again, 1. Some non-examples are 9x to the negative 2, right? So a negative 2, we can't have a negative in the exponent, and we can't have a variable in the exponent either, right? So any variable in the exponent, it's another kind of function that we'll talk about much later. But an exponent a variable in the exponent is not a polynomial. Another thing that is not a polynomial is if there's a square root, any sort of radical over the variable, right? So square root of x, and then a fraction in the exponent, again, is not a polynomial. Another example is if it is in the bottom, right? So if I have like 1 over x in the bottom, it is not a polynomial. All right, so we're gonna do some examples, rewriting the polynomial in standard form, state the degree, leading coefficient, and then classify by the number of terms. All right, so something like number 1, it is not in standard form just because all of our exponents are out of order, right? So I have a 3 and then a 2 and then a 6 as the exponents, right? I want the highest one to be first, so I want this 6 to be the first. I'm going to take that entire term, put it right in front, right? It's a positive 5x to the 6, so I'm going to put no sign in front of it. If you don't see a sign in front, it's positive. All right, and then our next one is a positive 4x to the third. All right, if it's positive and it's the second term, I'm going to write a plus, so 4x to the third. And then I have a negative 21x squared, all right, as the smallest exponent. So that's in standard form. Our degree is the highest exponent. Our highest exponent is 6. Our leading coefficient, we've talked about coefficients. The leading coefficient is just the one in front of the variable with the highest exponent. So in this case, it's going to be 5, and this is a trinomial. All right, we can try the same thing with the next one. All right, so in standard form, we have an exponent of 3. I have an exponent of 7. I'm going to take the one that has the exponent of 7 first. All right, highest exponent goes first. So I have 5y to the, minus 5y to the 7th, keep the sign with it, plus 6y to the power of 3. That is in standard form. Degree has the highest exponent. Leading coefficient is in front of the variable with the highest exponent. And then this has 2 terms, so it is a binomial. To add and subtract polynomials, we combine like terms. So ignoring the coefficient, the variables and the exponents must be exactly the same. So exact same variable, exact same exponent over those variables. And then all you do is you combine the coefficients, whether it's adding or subtracting, whatever sign you see. All right, so let's try a couple of these. So let's look at the first one. The parentheses just indicate which polynomial is being added with which one, right? So I have this binomial being added to this binomial, right? There's a plus in between, so we're adding. Now, all you do when you're adding polynomials, ignore the coefficient. You're looking for the exact same variable and exponent. In this case, this 4y squared, there's another y squared over here, so I'm going to combine these. And all you do is you combine the numbers in front, the coefficients, right? So 4 and a negative 7, combining those, I get negative 3. And then you keep the variable and the exponent exactly the same. And then same thing with whatever else matches. Negative 3 doesn't have a variable, neither does this 9, so we're allowed to combine them. That's going to be a plus 6, all right? Negative 3 plus 9. And that's all we got to do there. All right, super easy. You guys have probably seen this before. All right, again, I have another trinomial. I have a polynomial here plus another polynomial here. So then drop the parentheses, you're just combining like terms. So 5x to the power of 3 and another x to the power of 3. If you don't see a number in front, you assume it's a 1. So I'm doing 5 plus 1, 6, x to the power of 3. And then I have an x squared. I do see another x squared over here, 2x squared. So negative 7 plus 2 is going to get me a minus 5. And then again, keep the variable and exponent the same. And then I have a negative 3 with no variable. This 8 also doesn't have a variable, so it's going to be a plus 5. And then I have a minus x. All right. So the answer is fine like this. We don't love the way that this is written, though, because we want it to be in standard form typically. So just to get into the habit, I would like for you guys to practice writing these in standard form, right? So something like this now. We do like this more than something like this. And then when we get to factoring, you'll see that it does make the factoring a bit easier in the next lesson. All right, but otherwise, this is fine. If we don't specify in the directions, I'm okay with either. All right, so let's try the next one now. The only difference between number 3 and the first two are now that there's a minus between them. right? So when there's a minus between them, what I like to do is I like to change the sign of that minus to be a plus, and then change the sign of everything on the inside of my parentheses. So it becomes a negative x squared plus 2x minus 1. All right? And the reason that works is because you can think of it like a negative 1 being distributed to each of your terms, right? And then negative 1 times anything, it just changes the sign. And then from there, we can combine like terms just as we did before. So I can do a 2x squared minus x squared. That's going to be a 1x squared. 1 minus 1 cancels out. And then I get a plus 2x. All right, so this is our remaining polynomial. All right, doing some more the next one. Same thing as before, right? There's a minus in between, so I want to change that to a plus, and then change the sign of everything on the inside. All right, so now what we'll do is I'm going to take this 7x to the fourth, subtract 3x to the fourth. That's going to get me 4x to the fourth. I have a minus x squared and a plus 4x. That's going to get me a 3x squared. I have a minus 4x and a minus 3x. That's a minus 7x. And then there's nothing to combine with that too. All right, so that's your final answer. All right, this next one, when you see parentheses and brackets and you see like a whole bunch of different groupings, do your order of operations. You're going to do whatever's in the parentheses first, right? And if you look at each of yours, there's a lot of parentheses, but this bracket has the most things going inside of it. So we're going to try to simplify what's inside of this bracket first, right? And then doing that, we're going to get a y squared, a 3y, right? A plus 3y. And then a 1 minus 7 is going to get me a minus 6. All of that happens within these brackets, right? All I did was combine this binomial with this binomial. All right, and then I'm going to bring down whatever else was left over. So y to the third plus 1 minus. And then now it looks kind of like what we were doing before. I can change that minus to a plus, change that positive to a negative, another positive to a negative, and then a negative to a positive. And then we can combine like terms. Nothing combines with y to the third. Nothing combines with y squared. Nothing combines with minus 3y. And I have a 1 plus 6. That's going to get me 7. All right, so then we get this as our polynomial. All right, next one. If you have multiple polynomials, then just do whatever operation you see, and you're going to then just combine like terms. So if I see this minus out here, keep in mind this minus is only going to this binomial right here, whatever it's right next to, right? It's not going to go any further this way because this has a plus in front of these, right? So all I'm going to do is I'm going to change these signs to their opposite and then leave these alone. And then now that I did that, everything is being added. I can just combine like terms. So I have a 6x to the third, 3x to the third is going to get me a 9x to the third. Negative x squared minus 2x squared is going to get me a minus 3x squared. And then I have a 1 plus 2, which is 3, minus 4, which is a negative 1. And so we get this as our final answer. Now with multiplying polynomials, you're going to multiply your coefficients as normal, and you multiply your matching variables by adding the exponents, right? That was the very first lesson we learned, right? Multiplying variables with the same base, you add the exponents. So it's the same idea here. When you're multiplying binomials, you're going to want to FOIL those, right? So maybe some of you guys remember that we did that kind of recently in our radical section when we had to rationalize a denominator with two terms. So same idea there, same idea as whatever you learned in Algebra 1, right? That's typically something that I find a lot of people remember, but if you don't, we'll go over some examples like that. And then after doing so, you're going to combine any like terms that result. All right, so in this page, this is all going to be kind of the same method every time. You're going to notice that in all of these, it looks like there's going to be something that you can distribute, right? So it looks like in number 7, I can take that x and I can distribute it to each term in those parentheses. So again, think of this x having an exponent of 1. So again, you're going to add your exponents when the variables are the same. So 3x squared times x to the first is going to be a 3x to the third, right? 2 plus 1. minus x to the first times negative x to the first is going to be a negative x squared. And then x to the first times 1 is just x. All right, and that's all you do in that problem. Same thing here with the next one. I have a term on the outside of my parentheses. I'm going to distribute that term to each term in our binomial here. So negative 3 times 5, do your coefficient with the coefficient. That's going to get you a negative 15. X times the x, so x squared times x is going to get you an x to the third. Our next term, negative 3 times 2, coefficient with the coefficient is going to get you 6, so a minus 6. And then there's nothing to combine with the x squared, so it's going to be a minus 6x squared. All right, same thing with the next one. I'm going to distribute that y squared to each term in our trinomial. So a y squared times 4y squared is going to get you 4y to the fourth. Y squared times 2y is going to get you 2y to the third, right? You just end up with 3 y's. And then y squared times 3, nothing can combine there, so I'm just going to leave it as 3y squared. All right, number 10, same idea. I do have a single term multiplied by multiple terms. It's just written differently, right? So this one I can just go backwards. All right, so I can distribute 2y to the third times 2 is going to get me 4y to the third. And then negative 3 times 2 is negative 6. And then y times y to the third is y to the fourth. So this is a perfectly acceptable answer. I do also know that some of you would write it in standard form. Again, this 4 is our highest exponent. So I'm going to write that term first, negative 6y to the fourth, and then plus 4y to the third. Right? But unless I state in the directions, I don't really care how you write it, as long as you multiplied correctly. All right, so on this page, the difference with this page is that now it's not just a distributing problem, I have a binomial times a binomial. So all of these, what you're going to do is you're going to FOIL these, right? FOILing, if you remember, first, outer, inner, last. So I'm going to do first times the first. So starting with number 11, x times x squared, outer times the outer. So x times 4 is going to get you a 4x. Inner times the inner, negative 8 times x is negative 8x. And negative 8 times 4 is negative 32. All right, after doing this, sometimes you're going to be left with like terms. And you do want to combine those. So 4x minus 8x is going to get you a negative 4x. Nothing else can combine, so I would leave everything else alone. So I get an x squared minus 4x plus, minus 32. Same thing with the next one, number 12. First times the first is 3x times 5x, 15x squared. Outer times the outer, 3x times 7 is 21x. Inner times the inner is negative 10x. Last times the last is negative 14. Once again, combining your like terms, 21 minus 10 is going to get you 11. And nothing else can combine, so I would just bring everything else down. So I get 15x squared plus 11x minus 14 as the final answer. All right, same exact thing with the next one, number 13. I'm going to do first times the first, 2x times x. Outer times the outer, 2x times 5, 10x. Negative 4 times x, inner times the inner, minus 4x. And then minus 4 times 5 is going to get you a negative 20. Combine like terms, 10x minus 4x is 6x. And then bring everything else down. Nothing else can combine. So I get 2x squared plus 6x minus 20 as the answer. All right, the 2 kind of looks a little strange, but it's fine. That's a 2. And then lastly, I have 7x squared minus 2 as the first binomial, and the second one is 4x minus 3. All we're going to do is same exact thing. We're going to FOIL. First times the first, 7x squared times negative 3 is first times the first. 7x squared times 4x is going to get you 28x to the third. And then outer times the outer is going to get you negative 21x squared. Inner times the inner, negative 2 times 4x is going to get you a negative 8x. And then negative 2 times negative 3 is going to get you a positive 6. All right, so this is a case where there are no like terms to combine. Not always are you going to have things to combine. That's how it worked out in the other 3 problems, right? But this one, all of our exponents are different, so this is just going to be our answer. We can leave it just like this. All right, last page gets into some harder examples. All right, but I like to do these slowly. They take a little bit more time and you have to be a little bit more careful with your work. But it's essentially the same idea as before. All right, so what we're gonna do, I like to highlight in these problems, right? So I like to I like to kind of take each term. So I'm gonna take this term, this x, and I'm gonna distribute that to this entire polynomial. And then I do the same thing with the next term. So that positive 4 I like to distribute to this entire polynomial as well. And then so what that ends up with is we end up with an x times an x squared minus 2x plus 3. And then that plus 4 distributing to the whole thing is going to get you with a plus 4 times x squared minus 2x plus 3. All right, so in blue I'm going to distribute everything here. So then I end up with an x to the third minus 2x squared plus 3x. And then that plus 4 I'm going to distribute, and that's going to get me a 4x squared minus 8x plus 12. All right, and then once you're left with this, all you have to do is combine like terms. All right, so it looks like I have a negative 2x squared and a positive 4x squared, a 3x and a minus 8x, and then those are the only like terms that we have here. So then that's going to leave us with an x to the third plus 2x minus 5x plus 12, and then that's your, 2x squared. And then that is your final answer. All right, so hopefully not too bad. We'll do the exact same thing with the next one. All right, so when they get a little bit harder, again, I'm going to take that first term and distribute it to everyone. So I'm going to take that and distribute it to this entire trinomial here. And then same thing with this next one. I'm going to take that minus 3 and distribute it to everyone over here. I'm going to distribute it to that entire trinomial. All right, so then in purple, what we're going to be left with is a 2x times x squared plus 3x plus 5, and then in blue, that negative 3 is going to go to that trinomial as well. So x squared plus 3x plus 5. And then I'm going to distribute first that 2x to everything, and then you end up with a 2x to the third plus 6x squared plus 10x. All right, and then in blue, I can take that negative 3 and distribute it. So that's going to give me a negative 3x squared minus 9x minus 15. All right, and then from here, just like before, combine like terms. 6x squared minus 3x squared, 10x minus 9x. And then so I end up with a 2x to the third plus 3x squared plus x, and then minus 15. All right, and then they get a little bit harder when you have to do 3 terms times 3 terms. All right, so same exact idea. There's just going to be a lot more stuff on your page then. All right, so I'm going to have this first term, 2x squared. That's going to go to everyone. I have another term, a minus x. That's going to go to everyone. And then this time I have an extra one. So I have a plus 4. And then that's going to go to everyone. All right, so I'm going to take that 2x squared and write 2x squared times x squared plus 3x plus 2. I'm going to take that negative x and do negative x times x squared plus 3x plus 2. And then I'm going to take that 4 and I'm going to do a plus 4 times x squared plus 3x plus 2. All right. So a lot more terms. They get a little bit tedious, but hopefully not too difficult, right? So hopefully it's not crazy hard math that we're doing yet, right? So all it is, it's the same idea every time, just sometimes the problems get a little bit longer. All right, so in purple, this is what we're left with. And then in blue, I can distribute that negative x everywhere, so then I get a negative x to the third minus 3x squared minus 2x. And then in green, I can distribute that 4. So it's going to give me 4x squared plus 12x plus 8. All right, and then combine all of your like terms. We have a couple here. So x to the third, x to the third, x squared, and another x squared. And then I have just a regular x and a regular x. All right, so 2x to the fourth didn't combine with anything. The x to the thirds is going to get us a 5x to the third, right? 6 minus 1. And then 4x squared minus 3x squared is 1x squared, plus another 4x squared is another 5, and then an x squared. And then our x is minus 2x plus 12x is going to get me a plus 10x, and then nothing combines with 8. All right, so we get 5 terms in our final answer, right? So a little bit longer, but still the exact same idea. Let's try the exact same thing with the last one here, and then that'll be, and then that'll be it for this lesson. So again, take that first term, distribute it, take that second term, and distribute it, and then take that last term and distribute it. All right, so I'm going to take that first term, distribute it to everything, so 3x squared times x squared plus 2x plus 3. Take that second term, that 4x, and distribute it to get x squared plus 2x plus 3. And then take that minus 4 and distribute it to x squared plus 2x plus 3. All right, I'm going to start with the purple, distribute that 3x squared everywhere, and then we're left with a 3x to the fourth plus 6x to the third plus 9x squared. Take in blue that 4x, distribute it everywhere, we get 4x to the third plus 8x squared plus 12x. And then take that minus 4, and I get a minus 4x squared minus 8x minus 12. All right, combine like terms, nothing combines with 3x to the fourth. 6x to the third plus 4x to the third is going to get us a 10x to the third. All right, 9x squared plus 8x squared is 17x squared minus 4x squared is going to get us a 13x squared. All right, and then I have a 12x minus an 8x, that's going to get us a plus 4x, and then I have a minus 12. All right, so another big one that required a lot of work. All right, would I put like 10 of those on your quiz? Absolutely not. Maybe one of them, right? Because I know that these take a long time, but I at least want to make sure that you guys know how to do these, right? So will you see something like it? Maybe not a lot of them, but again, take a little bit more time, be careful with your work. But yeah.